Welcome to lesson 7.4. We are going to briefly talk for just a moment about the different types of reactions. So these first two sentences on the top here, we're starting here. Roman numeral 3, but types of reactions. There are basically five main types of chemical reactions. So let's list them out here. Synthesis, decomposition, single replacement, double replacement, and combustion. Most chemical reactions will fit into one of these five types. Very rare that there's something different. But let's just do a quick example and talk about each of them. So basically, synthesis is just like the word says, it's putting things together. But it's the combining, B-I-N-I-N-G, combining of two or more substances to form a compound. What we get is there's only one product that is formed. So we have two things, chemical reaction, then they're bonded together. So here's an example of phosphate and bromine combining to create monophosphate tribromide, I guess is how that would be called. So that is synthesis. These little sample things will be very helpful for you. Two things combining to form one. The next type of reaction is decomposition. That's where you have one compound that breaks apart into two or more simpler substances. So this time we have only one reactant, and it decomposes or it breaks apart. Right? Again, just like the word thing. So this time we have a product, we have a reactant that is combined, and it breaks apart into two separate things. The example equation here has hydrogen peroxide breaking down into water and oxygen, which it does in the presence of light. Is a very easy reaction, which is why your hydrogen peroxide is always stored in those dark bottles. And you should keep it under the sink, away from light as much as possible. Or you just have water. It's worthless. Anyway, that's decomposition, something breaking apart into two or more simpler substances. Next, we have single replacement. And in single replacement, because it's single, one element replaces another in a compound. Metal always replaces metal. Non-metal replaces non-metal. You'll never get where metal replaces non-metal at all. So this is what happens. Here we have the A and the B basically trading places. So then the A is with the C and the B is by itself. So here we have zinc and hydrochloric acid. And the zinc and the hydrogen switch places, the two metals, right? And you get zinc chloride and hydrogen gas. So now the zinc is with the chlorine and the hydrogen is by itself, where before the zinc was by itself. Okay? So that's a single replacement. One replaces another. So we have element compound. Now in a double replacement, we have two compounds. And basically, the ions in the two compounds swap partners. If you remember that show, you probably don't. You're probably not old enough. But there used to be a show on a long time ago called Wife Swap. This is kind of like Wife Swap, except not as dramatic. There's not as much yelling. Anyway, but the two basically swap partners. So the two metals trade places. So the cation of one compound combines with the anion of the other. All right, so you see here we have A with B and C with D. Then the A and the C switch places. So then A is with D and C is with B. Remember, the cation is always written first. So cation, positive, positive, negative, negative, positive A with negative D, positive C with negative B. So they just swap places. The fifth type of reaction is a combustion reaction. It is basically burning, combustion, something burns, right? It uses oxygen as a reactant. So in order to have fire, you always have to have oxygen, right? These combustion reactions produce a lot of heat, obviously. And the products at the end usually include water vapor and carbon dioxide. So here's the template for combustion. You have some sort of fuel plus oxygen. And what happens is you get a lot of heat. I'm going to write that down, heat. And then you usually end up with carbon dioxide and some sort of ash, water vapor, something there. But that's combustion. Important to know. Got oxygen as a reactant and usually water and carbon dioxide as products. Here's an example of that reaction on the next page. This is methane and oxygen to make carbon dioxide and water. Very briefly, I want to go over the energy that happens in these chemical reactions. We'll talk about it in more detail later on, but just very briefly. So during a chemical reaction, energy is used to break bonds. So you need to add in energy in order to break apart those bonds. And energy is released when new bonds are formed. So when two elements, two compounds, whatever, put together, it releases energy. But in order to break the bonds, you have to add in energy. So when we talk about energy, there's really two types of reactions. One is an endothermic reaction. It is a reaction that requires energy. So it needs energy to be put into it. And that is because the energy required to break the bonds is greater than the energy released by making new bonds. So here we have aluminum oxide. You have to add energy to that to break it apart to get aluminum, to make aluminum foil, right? It's got to come from somewhere. So this is what they mine and they find in the ground. It's an ore. They have to add energy to it to get aluminum by itself, and then there's oxygen left over. But then that aluminum is used to make aluminum foil. But that's an endothermic reaction. You have to add in energy. An exothermic reaction is a reaction that gives off energy. So the energy let go by making new bonds outweighs the energy required to break the old bonds. So this time there's more energy created in making those new bonds than there was to break the old bonds. That's an exothermic reaction. So here we have hydrogen and oxygen combining to form water. There's a lot of energy given off at that reaction. This is the reaction that powers the space shuttle, which there's a lot of energy left given off there because it's the energy that then the space shuttle takes to use to fly. Right? The rest of this we're not going to worry about. I just briefly wanted to go over the energy that came from chemical reactions.